Okay. Alright, we're good to go. Alright, hello everyone and welcome back to Data Vault. It's been a little bit, but we're back, and today we're going to be doing the second part of our coding stream. Hold on, there's something going by. But since last video, all I've pretty much done was I just added the debug statements. So in create account, you will see that if you go into the code, actually, I changed a few things. Just for example, the length of our IV string, I just made it as hexadecimal, so it's a little more readable. And then I also, so down here, I added the debug statement, so we'll just print a bunch of strings, so we can keep track and make sure everything's functioning properly. And then the biggest change is what you'll see with the logic here, is how I kind of surrounded everything in this method in dv-create-account with a big do-while loop. But you'll see that the condition on the while is false, and the reason why is because if I want to break out of something, I want to set the return code, but then or if I want to return an error, I need to free all of these variables that I'm not using. But I don't want to have to copy and paste the freeing statements for every single variable. So what I just did was I have a do while false. So this loop will only run once because this condition will never evaluate to true. So it will go through the first do, and then it'll see the condition and it'll say, all right, none of that. So we're not going to loop again. But what happens is if we run into an error, we set the return code, then break will break out of the do while false loop, and then after that we go ahead and do a conditional free on all of these variables. Now the conditional free here is simply just a method that I created that simply will call a function pointer if the value is not null. So if we have a null value, then there's nothing to free, so we're not going to call free. But anything that we do allocate, we need to free. Yes, we did. Okay. So yeah, return code we call load, and we never implemented this. So this will be to load in the data from the maps. So these are going to be the name to ID map, and the ID to IDX map, and then the category to ID map. And if you run this, what will actually happen is you'll get a bunch of run files here that we just pre-program the names for. And it's just category ID map.dv, etc. And this will be where the data is stored. So we can go ahead and get started. I'm going to start in datavault.h because we need to add some variables to hold these maps. So in datavault.h and datavault.c, and then I will also just open up the rest of the file so I can close the sidebar. All right, so in datavault.h we have another change that you'll see is that I just added a debug flag here. Set this in main.c to 1 if you want to have it debugging, otherwise it's just false or 0. So as of now we just have our data key, our key schedule, which we will actually use now, the random, the IV string, and then we have to add 5 new variables. So there's going to be the name ID map, which is an AVL tree, the ID IDX map, which will be a B-tree because it's useful for mapping integers to integers, especially in large databases, and then we have another AVL tree for the category to ID map. So the 2 AVL trees will be mapping strings to integers, and then the B tree is mapping integers to integers. So we need to go ahead and include those 2 files. So it's include lib/ds/avl.h, and then include lib/ds/btree.h. And then in the structure, we're just going to put them in here. AVL pointer name ID map, then our B tree, which is not a pointer, and it's just ID IDX That has been blasting. I'm sorry. That was a big mistake. I am sorry about that. Alright, the music is much lower. I forgot to turn it down after our last stream. Alright, but in OneNote, let me find it here. Yeah. Well, actually, it's not even in OneNote, it's in our sequences, but I'll just leave it, I'll just look at the diagram actually, because it's a little easier to explain. So we have our two IDs here, and the two numerical IDs. They're going to be the category ID here, and then the actual ID for the entry, which will be here. And what happens is we need to have some sort of value that gives us a maximum of that ID. So for example, the category ID 1, if we have 1, 2, and 3 occupied, and we add a new category, we want to add that with ID 4. So we need to have a counter or just some value holding the maximum. So it'll just be an unsigned integer max entry ID. This is for the IDs of the entry, and then unsigned character because we only have 1 byte to store a category ID. So max cat ID, just like that. All right. Now, so those are the only two things we need there. And then we need to reflect this in our initialization and deinitialization functions. So in dv and init over here, we need to just initialize our pointers, and we can simply just set them to null, and that'll be good enough. So dv.nameIdMap is equal to null. dv.catIdMap is equal to null. And then dv, or actually, yeah, that's it, because the other one is not a pointer. And then dv.maxEntryId is equal to 0, and then dv.maxCatId is equal to 0. I mean, I guess for completeness, we could say dv.idIdXmap.root is equal to null, just to, in case there's some trash memory there, but, or there's some trash address there, but we'll just explicitly set that to null. And then for kill, it's going to be the flip side, except we need to have a few more conditions here. We only want to free if certain condition, if there's actually a value there. So what we're going to have happen is we will call conditional free twice on this here. So we're going to free the maps now, and we'll call conditional free on dv, or actually, oh sorry, I misspelled that. So we're going to pass in the tree, the nameIdMap, so dv.nameIdMap, and then the function to use will be AVL free key. And we're going to want to free all of these strings, the keys, which will be strings, because we're going to be allocating them as we load, and we never deallocate them until we actually free the memory of the application. And then also, we want to call this again, dv.nameIdMap on just dv.nameIdMap. Or sorry, and just call it the free function on that. And then we set dv.nameIdMap equals null. So if dv.nameIdMap has value, it points to something, then we want to call free key on it, so we free all the keys, and then we will free the root node as well. This might actually take care of that. Oop, no, I wanted delete node key. It does actually. Would you look at that? We don't even need to do the conditional because delete node key already takes care of the if here. So we don't even need the conditional free. We can simply just call AVL free key on dv.nameIdMap and then set it to null. Just like that. And then we're going to do something similar for B-tree. So we'll call B-tree free and we'll pass in a pointer to dv.id idxmap. And this should also check for null. Yep, so if root, it'll do null. So this does a null check as well. And then also, this sets the root to null, so that's good there. And then finally, we'll do the same AVL free for the category ID map. So AVL free key, passing in dv.cat ID map, and then dv.cat ID map is equal to null. And then we do the conditional free on random, and then I guess we forgot to just say dv.random is equal to null by mistake. Forgot that. And then the last thing we want to do is just reinitialize the counters. So dv.max entry ID is equal to 0, and dv.max cat ID is equal to 0. Okay, so these this takes care of everything that we need. I'll add some more comments in a separate commit, but for now this is good enough. I'll leave that there for a second. And that's all we're going to need to do in the data vault structure. So we just added the 5 variables for the 3 maps and 2 counters. And then now it reflected that in our initialization and kill methods so that we can actually manage the memory properly. All right, now all we're going to be doing from the next part of this is just focusing on the dv persistence file. So we have the 2 methods that we need. I put their definitions, and then I also just wrote empty bodies there just so we could call them in the login and log out sequences. But now we're actually going to be looking at their contents. So since we don't actually have any methods to write data yet, we're just going to be doing the load, and then we'll test it on some data that I fabricate. But for now, we'll just leave it like this. Well, yeah, but once we actually get to adding the data methods, then we will be good to go on testing all this with real data. Okay. So dv load, or what you'll see about both of these, is that they have a very similar structure in that we're handling 3 different files, and each of the files we need to, at least for load, we need to decrypt them, make sure everything's working, and then load the contents, and then we need to parse the contents, and then free all the variables afterwards. And I'm just going to create a template way to do this, and then I'll just copy and paste it 2 other times, and it'll work just as well. So we're going to start by having our character pointer for the encrypted, which is equal to null, and then unsigned character pointer decrypted is equal to null, and then string stream. And then we're going to have a do while false here. Once again, just so if we need to break out, we can. And then at the end, we're just going to free our variables here. So we'll pass in to conditional free, need to include the file. So the conditional free was included in a library file. So /lib/util/mem.h. So conditional free. I misspelled that again. So conditional free passing in encrypted, and then free will just be the pointer, and then the same thing for decrypted. And then we also have, we will just need to call string stream free or clear, passing in stream, just to make sure that all works. And then we just, we'll also have our return code up top. So int ret code is equal to dv success by default. and then at the end we just return ret code. This is, so I'll just zoom out real quick just so we can have a few more lines on the screen. So this is pretty much where this is going to be the format of most of our methods. So we have our return code, then the variable initialization, then we have our do while, so the main body, like the actual functioning of this method. Then we have the freeing, and then return. So it creates kind of a nice symmetric structure around the actual main body, which is a nice organizational tactic. All right, so now we'll actually do the file reading. Once again, I'll write this once, and then we can pretty much just copy and paste it twice. All right, so we'll start by decrypting and loading name ID map. So what I will have here is a file struct file. I'll just call it that so we can reuse the variable. And then if file open, pass in a reference to file, then the path will be name ID map file path, and the mode will be reading binary. So that's the first one. Does it not light lights? Fuck it. And then else. All right. All right, so if this file does not open, then we need to return that it doesn't exist. So return dv file dne. Or sorry, not return. Say ret code is equal to dv file dne, and then break. So we're going to break out of the do while loop here. Or break out of the main body. This is kind of a workaround for our goto. The goto that I think exists in C#. I'm not sure if it exists in C++, but that's kind of like that. This is kind of like that. All right, so if the file is not open, then the file does not exist, so we have an error. Next check we want to make is if name ID, if file.len. So if the file has length, then we want to read. Otherwise, we have nothing to read, but there was no error, so we just return that there's nothing. Like as of now, in our run files, name ID map is empty. However, that's not a problem because there's nothing to read, so it doesn't really matter. So all we're just going to do is close the file. So file close, and we're going to pass in a reference to file, and then we will just proceed from there. All right, now to read, we're going to first get the encrypted contents. So encrypted is equal to file read, passing in a reference to file, and then the name, or the number, which will, or the length, which will be file.len, and then we're going to decrypt. So AES decrypt, and now here's where something cool happens. We can call with schedule because we pre-computed it. So instead of having to compute the schedule every time we want to call an AES method, we can just use the schedule that is already that exists within the DV app. All right, so we're going to call it the cipher will be encrypt or ENC. The length will be file.len. Subkeys will be dv.aes key schedule. The number of rounds is AES 256 number of rounds. The mode will be AES CTR. The IV will now be dv.random plus some offset, and we need to include that. So I'll just say offset to make it to force us to include it, and then the output will be a reference to decrypted. And then we're just simply going to pass this into our string stream. So stream is equal to string stream allocate, and we're going to pass in name ID file dot length as the size, so we just pre-allocate it. And then string stream read, passing in a reference to stream, decrypted, and name ID file, or sorry, file.len. This also has to be file.len. And then after we pass it into the string stream, we're going to free our variables. So free encrypted, free decrypted, and then close the file. So file closed, pass in a reference to file. And then now we're going to parse. And this is our to-do section. And then after this, we just free this string stream. So string stream clear, passing in a reference to stream. And this is going to be our structure here. I'll actually just put the path here as just that so we know to switch it out for everyone. So I'm sure there's an easier way to do this. I'm almost certain of it. But I mean, I don't like that I have to rewrite this 3 times because this is kind of annoying. You know, let's do it. Let's make a helper method here. So we'll have a return integer dv parse. We're going to pass in the app, so dv app pointer dv. And then the things that we need to pass in are the path, so const character pointer path. And then we need to pass in an offset, so that's going to be an unsigned int offset. So this is the offset of the IV. And then we're also going to need to pass in this little parsing callback here. So in order to do so, we're going to need to define that. Sorry, give me 2 seconds. All right, let me actually just grab it from here. And then parse will take in, or wait, hold on. No, yes, this is good, this is good. And then we need to pass in our read function. So this will read the stream, and it has to take in these 3 values. So the application, the path, and then the offset. So we need to pass in these same 3 variables in our little argument list here. So we're essentially passing in our application, the path, the offset, and then a pointer to a function that will read the individual function, or that will read the individual file. So what we can do now is just take this the current body of the do while, so decrypt and load name ID map, just take everything there, cut it, and then paste it in dv parse. So dv parse will now open up our file, and we need to define our encrypted and decrypted strings. So character pointer encrypted is equal to null, and then unsigned character pointer decrypted is equal to null as well. And then we need to pass in our path that as the parameter, and then also the offset. So those 2 are specific to each file, and then our string stream we also need to define. So string stream nothing yet. So we allocate, and then we need to call the actual parse method here. So what this will be is the read function. We pass in dv, and we don't need to pass in the path. I'm sorry. We don't even we actually don't even need to pass in the path or the offset. We only need to pass in the actual application structure to the read function, because this only takes in oh wait, sorry, we need to pass in the decrypted value. That's my mistake. Or the string stream, sorry. So we need to pass in a string stream because we need to pass in the decrypted value here. So read function takes in DV and then stream as well. All right, just like that. And then what we can do is in the else statement, so if the file was not opened, then we return dv file dne, so that doesn't exist. And then otherwise we're going to return dv success. Okay. So now what we have to figure out is the read function. So let's actually define our 3 little read functions up here. So we have our parse, which is a helper method that we're not defining in the header file, but we're just going to keep it over because we don't need it in the header file. We don't want anyone to call it apart from dv load. So our 3 helper methods, they'll return void for now. So we'll have read name ID map, and they all have the same parameter list. So we'll have the dv app pointer dv and then string stream. And then the same thing for void read this will be read ID IDX map, passing in dv app pointer dv and string stream. And then void read cat ID map, passing in dv app pointer dv and string stream. So these are going to be our 3 helper methods here that we pass in for each of the files. So now in our dv load, what we have to do is we're going to call we're going to call parse on the 3 files, but we need to get the return code every single time. So we're going to say if ret code is equal to parse dv parse, and we're passing in the application. The path will be name ID map fp. The offset I'm still going to figure out, and then the function pointer will just be read name ID map there. So if this returns a value, then we break out of here. And this should actually be dv there. And what we can also do is, now that we don't need the variables, we can just delete those because we do not need to free them at the end. They're taken care of in the dv parse method. All right. And what I want to do now is I need to figure out the offset. So currently we have the offsets defined in the controller file. So I believe the only thing that's in order is that we include that that controller file. So include dv controller.h, and then for the offset we're just going to pass in name ID IV offset. Let me actually just align this a little better, just like that. All right, so decrypt and load name ID map. Then we're going to do the same thing for decrypt and load ID IDX map. So it's going to be if ret code is equal to dv parse, and we're going to pass in dv. The file path here will be ID IDX map fp. Offset will be ID IDX IV offset, and then the function pointer will be read ID IDX map. So this is all stuff specific to each file. And then break, because if the return code is non-zero, then we encountered an error and we want to break. And then it's going to be the same thing for the last one. So decrypt and load cat ID map. So if ret code is equal to dv parse, pass in dv, file path will be cat ID map fp, cat ID IV offset, and then read cat ID map. just like so. And then if that returns a non-zero value, then break. Category. All right. So in DV persistence, in the load method, we're simply just calling this parse method on each of the 3 files. And this parse method encapsulates everything, the reading and the decrypting, and then just calls the parse method, which is specific to each of our files. So now let's work on these 3 helper methods here. Okay. So for our name ID, let's go back to OneNote. Name ID, which we said was in map.dv, but it's not, is just we do a string, which is a name, so that's just a single string, and then a 4-byte integer representing its its ID. So we're going to have a few counters here, or a counter and 2 other variables. So we'll have a start of entry IDX as an integer is equal to 0, and then we're going to have a character pointer name is equal to null, and a character pointer ID string is equal to null. So these will be values to store. So then we do a for integer I is equal to 0, I is less than stream.size I plus plus. So we're just going to iterate through every character in the stream. And then we say if not stream.str at I, then we have encountered the end of the string. And we know that we're not going to have a 0 otherwise because we start in a name, and this also isn't random encrypted data. We've already decrypted it, so it's only printable characters that you can enter through your console. All right. So what we're going to do is we're going to get the name. So let me just zoom in again. So we're keeping track of the start of the name, which is initially 0. And we say name is equal to string stream, substring range. And we're going to say a reference to stream. And we're going to go from the start of the entry IDX to I. So to the current value, which is the 0 character. So the start of the name up until I, which is the current terminator character, and that's exclusive, but we will substring range actually terminates for us, which is awesome. So it will set that last character to 0. So when we pass in this string to a comparison method, it will actually return it will actually interpret it as a good string. And then we get the ID string similarly, but it's going to be string stream substring length this time, passing in a stream, and we're going to start from I plus 1 and go up to 4, and we're going to do 4 characters because it's a 4-byte number, and then we're going to insert this into the tree. So dv.nameIdMap is equal to AVL insert. The root will be dv.nameIdMap, and then the key will be name, and then the value, it's an integer, but we're going to cast it to a void pointer. The value will just be the integer value of the ID string. So we're going to cast it to a void pointer and then call small endian string, which we need to include, or small endian value on ID string, and 4 for the number of bytes. All right, damn it, it keeps wanting to do that. Let me go up top and include our number IO file that we need. So at the top here, I'm just going to go ahead and include /lib/cmathematics/util/numio.h. So this gets the small endian value here. All right, so All right, and then we're going to update our cursors. So we're going to say start of entry IDX is going to be after the number. So we need to go the current terminator plus 4 bytes, and then the next one. So I plus 5, and then I plus equals 4. And what that does is we essentially just move it up to the end of the number, and then I plus plus at the end of the loop will take care of that. And then we need to free, but we're only going to be freeing the ID string because the name string needs to be kept in this map here. But the name will be freed. All the names will be freed when we kill the app, or when we when we kill the app, because we call AVL free on the keys. So the keys will all be freed. And that's that for read name ID map. Good stuff there. So yeah, we go until we find a terminator character, get the name, which is up until the terminator character, get the ID string, which is the next 4 bytes, parse the integer, and then pass those values in as a key value pair into the name ID tree. All right, for ID IDX, it's going to be a little simpler, or it's going to be a little more structured, just because we're going to have a character pointer num string is equal to null, and then an integer ID and an integer IDX. And then we're going to do another for loop, which will iterate over everything. So for integer I is equal to 0, I is less than stream.size, and then I plus equals 2 times the size of an integer. I'm just doing that for explicit sake, but just to kind of allow us to know, okay, we're advancing 2 integers, and that we can kind of figure that out later. So we're going to start by getting the first integer, because in this one, in B-tree, it's just 2 4-byte integers placed right next to each other. So num string is equal to string stream, substring length, passing in a reference to stream, I, and 4. 4 is the number of characters, and then ID is equal to the small endian value of the number string, 4 bytes, and then we free the number string, and then we do the same thing for the index. So num string, get a substring of 4 characters, then get the small endian value from the num string, 4 bytes, and make sure you assign it to the index, and then we are going to free the number string again, and then insert. So we read and parse the ID, and read and parse the index, and then we're going to insert into B-tree. So B-tree underscore insert, passing in a reference to dv.id idx map. The key will just be the ID, and then the value will be a void pointer to index. So it doesn't matter that we're casting it to a void pointer, we're still going to interpret it as an integer. And then we're going to update our counter, the application counter. So dv.max entry ID is equal to the max value of dv.max entry ID and ID. So we're going to update it if the current ID is more. All right, and then, yeah, so that's all we need there. And then we don't need to update any cursors because I plus equals 8 over here. So we advance 2 integers. And then we're going to read category ID, which will be very similar to the name. So I'm actually just going to take no, we're not going to try that. No. Yeah, we'll just rewrite it all over again. So we'll have an integer start of entry IDX is equal to 0, then character pointer name is equal to null, and character pointer ID string is equal to null. Then we're going to do a for integer I is equal to 0, I is less than stream.size, I plus plus. If not stream.str at I, so we have found a terminator character. So we're going to say the name is equal to the substring up until the point. So substring range going from start of entry IDX to I. And then the index, the ID string is going to equal this substring length, passing in a reference to stream, going from I plus 1 to, and it's only going to be 1 byte because our category IDs are just numbers. They're just bytes, unsigned characters. I reverse the order. I wanted to do the name first, and then we go to the category, or then the ID, just to make it more like the name ID. Alright, so I'm just going to count it in a string. So we're going to insert into the map and then update our cursors. So dv.catIdMap now is equal to AVL insert. And we're going to pass in dv.catIdMap. Name is the string, and then the value will be a void pointer conversion of the small endian value of ID string in 1, because it's a single byte. And then we advance our cursors. So I plus equals 1, which is just to move it up 1, but it's going to be moved up another 1 past the ID after in the next iteration. And then start of entry IDX should be equal to I plus 1, right? Because I is currently, and why did I do 5 in the other one? Should it be I plus 2? I think it should be I plus 2. Because, yes, it should be I plus 2, yes. And then we're going to free ID string, but not name. Once again, because we need the name for comparisons in the tree. We need to keep that as a allocated variable. All right, and that's that. That's the load sequence. It's pretty cool. I mean, this new little parameter system works, or it seems to be better. I don't want to count my marbles just yet because it might blow up in my face, but I like this a lot better, just because otherwise we'd be copying and pasting this thing of reading the file, then decrypting it, and we're going to be doing these if statements over and over again, and it would not be very fun. So now that I'm encapsulating it into methods is something cool. All right, so that's load. Now for save, I would like to think that okay. So for save, I'm going to do something similar. We're not going to need any variables except our return code. But we actually don't even need a return code. Well, do we? Yes, we do. So we need a return code and a do while false. And then at the end, we return code. So int ret code is equal to dv success do while false, and then return ret code. So I'm doing something on the fly here as well. And it'll be an integer, or a method returning an integer. dv stringify. We're going to pass in a dv app pointer dv. And what I would like to do is, let me just look at the above code, sorry. So we're going to pass in the app. We need to pass in a file name and an offset. So a const character pointer file. Is that what I pass in up here? Path, sorry. An unsigned integer offset. And then we're going to need a few more things because I don't want to, it's not worth it to have more helper methods because I already described a few. But I'm doing something a little interesting here. Okay. So what we're going to do is we are also going to pass in a void pointer for the structure to write. So void pointer for the structure. This is going to be the structure that we want to write. So it'll either be the name ID map, the ID IDX map, or the cat ID map. But then I need another, a function callback. All right, a function callback that takes in a function callback that takes in the structure itself and then a string stream. Yes. All right. So it just needs to take in a function structure, or the structure itself and the string stream. So this will be void, if I remember my callbacks properly. So we do void, then in parentheses pointer for dump function. And the parameters will be the structure itself, so void pointer structure. And then a string stream. So this is kind of similar to what we had before with the function here, taking in some pointer and then a string stream. But this time it's going to be writing to a string instead of reading from it. All right, and then we're going to have a few more helper methods here. So we'll have void write name ID map. And this takes in a string stream pointer. Or sorry. Yes, this needs to be a string stream pointer that we take in as input to that function pointer. So string stream pointer stream. And I also want to take in our AVL pointer, which will be the name ID map. And then that's that. Wait, it should be the other way around because that needs to match this. So the map first and then the stream. Or do I have it the other way around in the helper? No. It should be the map first. Sorry. Name ID map. Parameter list is map first and then the stream. And then we're going to do something similar for the category ID. So void cat ID map, or write, sorry, cat ID map passing an a B-tree pointer ID IDX map and a string stream pointer stream. And then the same thing for void write cat ID map. And this passes in an AVL name ID map and a string stream pointer stream. All right. And then what we're going to do now is, since we are working with trees that we don't know the height of, we're going to be doing a depth first or whatever type of traversal through the tree. So I want to create a little bit of, I'm going to create another set of helper methods. This is getting a little confusing, but let me actually just write the base code now and then we'll get into the details. So we'll start and save. So save is pretty much going to be the same as load. We're going to get the return code of each call and then break. So we're going to say if ret code is equal to dv stringify, and we're going to pass in dv the app. The path, the first path will be our name ID map fp. The offset will be name ID IV offset. This is just the offset of the IV for the file, and then we're also going to have the structure, which will be dv dot name ID map, and then the callback will be write name ID map. And this, if this returns anything, then we break, and return code is automatically assigned. And then we're going to do the same thing for the other two. So if ret code is equal to dv stringify, pass in dv, this time it's id idx map fp, the offset for id idx, then the structure will be a reference to dv dot id idx map. We need to create a pointer to it, and then the dump function will be write id idx. Did I not? Oh, I didn't do that. Should be write id idx. I miswrote one of the names here. Write id idx map. And if this returns anything, then we break and return the code. And then finally, if ret code is equal to dv stringify, pass in dv cat ID map, the file path, offset. This time we just say dv.cat ID map, and then the dump function will be write cat ID map. Like so. So this is it for save. We're just going to do each of the three files just like we did in load. It's just the other way around. Now for Stringify, this is going to be the generalized structure that I wanted to avoid copying and pasting 3 times. So we're going to first get the value. So we're going to have our file struct file, and then we're also going to have our string stream, and then if file open, and we're going to pass in a reference to file, and then the file, the path, then the offset, well, we're not going to use the offset, and then the mode will be WB for writing in binary. And if this succeeds, then we want to write. Otherwise, we're going to return dv file dne. So file does not exist, return the error. So now we're going to stringify. So we're first going to allocate. So string stream out is equal to string stream allocate default. And then we need to pass this into our recursive function. So it's going to be write name ID, or sorry, write, this is just going to be the dump function. We're going to pass in the structure, which is just the structure, and then the string will be, the stream will just be a reference to out. And then, this is going to be our generalized function, or that we're going to specify for each of the 3 maps. Then we encrypt. So unsigned character pointer encrypted out is equal to null. And then we're going to encrypt the output. So AES encrypt, once again, we can use the with schedule now because we've already pre-computed it. So what we're going to do is we're going to pass an out.string, out.size as our input. The subkeys is going to be dv.aes key schedule. Number of rounds is AES 256 number of rounds. Mode is AES CTR. Then the IV will be dv.random plus offset. That's where the offset comes in. And then finally, the output will be a reference to encrypted output. Like so. Then we're going to write this to the file. So file write, pass in a reference to file, write the encrypted out, and then out.size, because AES CTR will actually just encrypt a message to the same length, because it doesn't actually perform AES encrypt on the blocks, and it performs it on a counter, and then it will XOR that with the blocks. And then we're going to do file close on name ID file, or sorry, on just the reference to the file, and then free our variables. So string stream clear, pass in a reference to out, and then free encrypted out. All right. And that's our wrapper function for each of the maps. And all we need to do now is just specify the dump function. So we just have these 3 methods left to do. So you're going to hate me for this, but we're going to write 2 more helper methods. I will document these methods when I write the commit, but the purpose of this is we have a recursive function. Since we have trees that have an unspecified length, it's not like we're just writing to and from arrays or to and from lists that we know the length of. We have trees that may have a lot of elements in them, and we don't know what the hell their size is. So we need to have a recursive method that does our traversal for us, and then it will incrementally add stuff to our output stream here. So what we need to do is have 2 extra recursive methods. And the reason why it's only 2 instead of 3 is because write name ID and write cat ID are the same thing. It's just they have a different key length. So, or a different ID length. The category has an ID of 1 byte and the name has an ID of 4 bytes. So what we have to do now is simply just write these recursive methods. So first one's going to be void write name ID, or write string ID. We're going to pass in a string stream pointer out, an AVL pointer root, and another similarity is that we have AVL trees here, which is awesome. And then an integer for the ID size. So this will be the size of how large our value is. And what I'm going to do is I'm going to well, I'll just do this right now, and then I'll write the other definition too. Void write ID IDX, passing in a string stream pointer out, and then the only other input is just the node. So B-tree node pointer root. So we're passing in the roots of subtrees to these recursive methods, and then we recursively go down into those subtrees that are below that, so on and so forth. All right. So we'll start just by calling these methods. So in write name ID map, we're simply going to call write string ID, passing in stream as the output stream. Our root is name ID map, and the size will be the size of an integer here. Then for write ID IDX map, it's going to be write ID IDX. We're going to pass in the stream as the output, and then ID IDX map dot root, because we're going to start at the top. And then we'll do all the null checking in the recursive methods. And then for the category ID map, it's going to be the same as write name ID. So we're going to do write string ID, passing in stream, then category ID map. And then this time the ID size will be the size of a character. Like so. All right, and then now what we shall do is let's write our recursive methods. And then once we're done with this, I will once again go through the process of this and how it works. And I know it's annoying to look at, but trust me, this will help a lot. We're already down on lines. I'm looking on my reference. I know we're not done, but we're going to be down on lines. All right, so for the name ID, for the string ID, we're reading from an AVL tree, and we want to output a string. Now, I did put it like 2 seconds of thought into this, not much, but I think it's helpful. When we build our AVL tree, we're going to be building it in the order that that we determine at runtime. To kind of alleviate the stress of having to rebalance a tree, why not just take our balanced tree and write it in the order that it's in, so that when we read it from memory, we won't have to rebalance it. And the only way to do that is to do an in order, or do a post order traversal. So the post order traversal says we write the root first, then we go to the left child, and then the right child, and then we do their children, so on and so forth. So what this means is, yes, yeah. I'm actually rethinking this. This might not actually work. I think this is a good way to do it. I know for the B-tree, the way it works, or the way I have it works well. But this just allows us to avoid some of the rebalancing, but I'm not sure it works intendedly, because it will build one branch first. Yeah, this is unfortunate. It's going to build one whole branch first, because we're doing it recursively and we're not doing it with a stack. Okay, that's fine. But I mean, if we did a post order, would it work? No, I don't think it will. If we had a stack, we could, but I don't want to use a stack. I just want to do this recursively. All right. So we're going to do a post order traversal. It can alleviate some of the pain. So if root and root.key, then we have values to write. So we're going to visit the root. So unsigned character pointer name is equal to root.key. We're just doing an implicit cast, because root.key is a void pointer. And unsigned integer ID is equal to the unsigned integer conversion of the void pointer root.value. And then an unsigned character pointer ID string is equal to the small endian string. Make sure it's small endian. And we're going to pass in the ID. So we convert everything to a string. And then now we're going to, the format will be entry.name \0, and then the the string value of entry.id. So it's string stream concatenate. We're going to pass in the output. Hold on. Root.key is a string. It is a string, and it has a terminator character. And therefore, it does not need we don't need to explicitly put another terminator character at the end. So what we can do is just concatenate using a format %s, and then will just be name there. And then we need to read from the input string, and we can't just do a %s because this may have zeros in it. So the compiler or during runtime, it'll see, okay, we have a 0-byte string, because if the first byte is a 0, which will likely happen for most of our IDs, then we cannot allow that to happen. Then it will just stop writing. So we need to say string stream read, which takes in void pointer data, and we pass in the output the ID string and an ID size. Then we're going to free the ID string. We cannot free the name because this is attached to the node, and then we visit the children. So if root.left right name ID output root.left ID size, and if root.right right name ID, sorry, this should be right string ID, my mistake. Passing in output root.right and then ID size. So ID size will stay the same on the entire tree. So we're just going to pass that along through the methods. All right, so that's that. I'm going to figure out this. But this works. What we could also do is just copy it from memory, but I mean, yeah, let's just do that. Let's do string stream read, and the output, the name, and then the string length of the name plus 1. So the name is a printable string, has ASCII characters, just like we want, ones that we can see on the console. We get the string length of this and do a plus 1 because we want the terminator character at the end. So what will happen is, oh, okay, I think I know what was going on. When I did string stream concat with only the %s and no explicit terminator character, what was happening is the string stream was just putting a temporary terminator character there, but then it would move it after the string afterwards because it still wants a string, or it still needs it wants to have the whole thing before the terminator character. So we're just going to have read here, and this will work because this will explicitly copy the 0 in this string. All right, and then we visit the children. For IDX, we're going to do an Inorder Traversal. And I believe this should also alleviate some of the rebalancing, because, well, I mean, even the addition or insertion doesn't really need much rebalancing on a B-tree. But this will help because it kind of builds it in the order that we want it to without doing any crazy shit, bouncing back and forth. We're just doing it least to greatest. So if root, we're going to say integer I is equal to 0. And then for empty first condition, I is less than root.n, I++. Now remember, this is a B tree. We have child, then value, then child, then value, then child, then value, blah, 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 blah. So what we're going to do is we're going to do in order. So we need to go to the left child first, then so children at 0, then value at 0. Children at 1, value at 1, all the way up until value at n, and then we do children at n plus 1. So we traverse to children. So if root.number of children, then write ID IDX, sorry, write ID IDX, yep, passing in the output stream, and then the root will now be root.children at I. So we're taking the substring, the subtree rooted at this child. And we only want to write children if it has it. So if this is a leaf node, this condition will evaluate to false. And then we write the current key value pair. So we need to convert both to integers. So unsigned character pointer ID string is equal to, or just num string is equal to null for now, just to allocate one variable. Then num string is equal to small endian string, passing in the value, which is root.keys at I. Then we're going to write this, so string stream read, passing in out. The data will be num string, and then the length will be 4 because it's an integer. And then we do num string is equal to small endian string of root dot, the unsigned integer conversion of root dot values at I. So we want to convert this pointer that doesn't point to anything, it's just an integer. And then we just say string stream read, passing an out, num string, and 4. So it just concatenates them together, just like that. And then we free the num string. And then afterwards, we still have one last child, the last child to read. Because once again, there's one more child than there are keys in a B-tree. So we say if root dot number of children, then we're going to write ID IDX, passing an out, and root dot children at I. Okay, so this is an in-order traversal. We go through smallest keys, we go down as far as we can, get the smallest key, then we start writing key values, go up to the last child. And this is recursive. All right, so let me go ahead and explain the save method from the top here. So save, we get our return code and we start our main body here. And what we do is we have this wrapper method to read each map, and each map takes in the map and a function pointer that writes that specific map. So instead of copying and pasting, because Stringify, all Stringify does is it takes a file, opens it, calls the Stringify on the map, then we encrypt those contents, write the contents to the file, and free the variables. That's all the same for each of the 3 maps. So we just have a wrapper method, rather, that we can just call on each of the 3 maps. So when we call dv Stringify on, say, name ID map, we pass in the dv structure. We need this for the offset, the IV for the encryption here, and the key schedule as well. So we have the application, the path, which is the path to the file to write, and the offset, which is the offset of the IV that we'll need for the encryption. Then we pass in a void pointer of the structure that we're actually writing in. And then we have a function, another function pointer that will dump the contents of the current structure into a string stream. So in Stringify, we open up a string stream, open up a file. We're going to read into the string stream, which we don't know the length of yet because we don't know the size of these trees. That's why we allocate default here. Then we call the specific dump function, which we specify up to above. Then we encrypt that output, write the output to the file, and then free our variables. Now for the actual callbacks, that's these 3 up here. Write name map, write ID IDX map, and write cat ID map. These in turn will call their own recursive methods. We could make these recursive, but I want to separate things a little further. I don't want to make one of them recursive and the other 2 not, but we have to we can add more optimizations, especially with the name ID and the category ID, because these have the same format since they're both AVL trees mapping strings to numbers. It's just the size of the number the size of the number varies. So the string ID the name to ID maps a string to an integer, 4 bytes. And the category ID maps a string to a character or a single byte. But then the ID IDX map maps an integer to an integer, so 4 bytes to 4 bytes, but those are both numbers. So these three methods we'll call recursive methods since we don't know the size of the tree, which is once again why we're using string streams that are dynamically allocated. And then here we're going to call, we'll start with write string ID. So it does a post order traversal. We visit the root, get the name, get the ID as a string, and then get the ID as a number, and then convert that ID into a string. And then we're going to read that string into the string stream. And once again, we're being careful not to free the name because that we want that in the tree. The freeing of all these names takes place in, if you guys remember, dataVault.c right here. Kill. In free key, we free all the keys of name ID map like that. All right, so we get our name, get the ID, convert those to strings, read them into the string stream, free the ID string, not the name string, and then we go to the left child recursively, and then the right child also recursively. Now for write ID IDX, it's a little simpler since we're just, that's not simpler. We're doing an Inorder Traversal of a B-tree, so we check the root, then have our counter, go to the children because the children to the left of a node are less than, if I can get my algorithms, B-tree. So you can see here, this is our little B-tree here. We have the root node and everything to the left of it is less than it. So doing an Inorder Traversal requires us to visit the left child first. Then we go through the actual keys and values. All right, so we do left child, then left key. And then we advance our cursor. And then after all the keys have been written, then we have one last child because they're in a B-tree node, you have one more child than there are keys. So we just do that last child there. Once again, checking if it's a leaf node or not. All right, so I'm going to build this. I'm not going to test it just because this is taking a little bit longer than I would have liked, but I will be doing our tests and I'll upload them on a commit. So if I'm just going to run, all right, we have some errors here or possibly warnings. Doesn't like our function pointers. Wonderful. All right, so warning, passing argument 5 from incompatible pointer. This is an AVL. Expected void pointer in string stream, but got a void AVL pointer in string stream. So I think it wants us to explicitly cast our structures to void pointers. Hold on. Stringify. Oh, yes. And then I screwed up something here. In DV Stringify, make sure to pass in the file path first and then the offset. So ID, IDX, IV offset. And then it's getting angry at us about the values here. So just, if you want to avoid those warnings, explicitly cast all the maps to a void pointer. Doesn't like that. And let's try this again. All right, we still have some things to work on. All right, this is back here. All right. All right, so passing argument 5 from incompatible pointer type. Oh, I know. We don't need to convert. We didn't. Sorry, that was not the issue. It doesn't like that we have these our little functions here, the right name ID map, right ID IDX map, and right cat ID map, taking in non-void pointers. So what we can do is just pass these in as pointers and then just convert them to whatever they are. So in name ID map, we're going to convert the void pointer name ID map to an AVL pointer. Then for the ID IDX map, what we need to do is first convert in parentheses ID IDX map to a B-tree pointer. So ID IDX map. And then from there we take the pointer to the root. Like so. And then do the same thing for the cat ID map. Just converting it to an AVL pointer. And good. No more errors. Or warnings, at least. Good. All right. So that is load and save. I'm going to upload tests for this in a bit. But for now, that's that. In the next video, we will actually be able to start writing our data or starting with creating entry. I'll probably just record a video instead of streaming it. But then once we do create data and access data, that's going to be a stream likely. And then we'll start getting into doing our console view before we start doing edit data and delete data. But yeah, that is all I have for you guys today. I hope you guys enjoyed. This is Data Vault. It's moving along pretty well, but I completed the most of it on my own, and it's kind of falling off, but I'm going to try and keep going with it. So until next time, I'll see you guys then, and take care of yourselves. Have a good one.